when I actually shuts the backstage off, then people would be able to see the live event. Does that make sense? But yeah, we'll get started shortly.
Oh, sorry. One more question. Are you going to? So should we plug ourselves during when we're doing our 10 minutes, or are you going to give us a few minutes at the beginning to introduce ourselves, or?
Great question. We can do in the beginning. I think that's okay. Then audience would know when you start who the folks are. So yeah.
Cool.
Some folks have joined in, so I'm going to put the backstage closed. Hello, we are live now. I think there's few folks who have already joined in, actually 15. So I'll let folks to trickle in and welcome everybody. It'd be great to know where you're dialing in from. So if you don't mind just putting that in the chat, that'd be great. I'm Satya, I'm dialing in from Seattle, and I'll shortly introduce the other folks as well. But let's introduce ourselves in the chat if that's okay. And I think summer is officially over in Seattle, so it's fall and winter is coming. Hopefully, wherever you're dialing in from, you have a bit of sunshine. If you like sunshine, I guess. If you don't, then you should check out Scotland. It has a nice cold weather. I used to live in Scotland, so I find Seattle much nicer than the Scottish weather. Oh, great. We have some folks from Seattle as well. That's awesome. And the Bay Area. Then we've got folks from Toronto. Welcome, folks. Okay, while we're waiting for other folks to trickle in, just want to give a bit of background of how this session got put together. So within the SciSpot community and our customers, there was a lot of question and interest around running lab as a code. So when they use LIM system, traditional Yelin systems, bringing all the data together and then be able to orchestrate that as a JSON code was one of the top questions that everybody from the community was asking. So that's how this event got together. And we've got two amazing speakers joining us today. So I'll let them introduce themselves shortly. If you don't know me, I'm Satya. I'm co-founder of SciSpot, which we like to call the best tech stack for modern biotech. And so we have Jesse and we have John joining us. I'll let them do a brief introduction. Jesse, do you want to go first?
Sure. Thanks, Satya. I'm Jesse Johnson. I've been working in software and data engineering for about the last 9 years, and the last 4 of which were for small biotech startups. And I just recently started my own consulting shop. So it's called Merologic, which is at merologic.net. My goal is to help biotech teams biotech startups get their data under control so they can focus on the science. I also have a weekly newsletter called Scaling Biotech, which is on Substack, so scalingbiotech.substack.com, where I write short pieces about data in biotech and of course some of the topics that we're going to talk about today.
Brilliant. And I'm a big fan of Scaling Biotech. It has helped me to think through the SciSpot architecture as well. So I'll definitely recommend that newsletter. John, do you want to do a quick intro as well?
Yeah, absolutely. So my name is John Whitaker. I'm the principal lab automation engineer at Invitae. I've been working in lab automation for about a decade now. And Invitae is a diagnostic genetic testing company. So we do a lot of automation in our lab. The lab automation for our processes sort of operates as the factory that kind of gets samples ready for sequencing. So we kind of deal with some unique problems in the lab automation space once you get up to a pretty large scale. So yeah, happy to be here and excited to dive into it.
Brilliant. And John and I have had a lot of back and forth discussions because we're both animated and excited about where lab as code and lab automation is heading. So looking forward to double clicking on some of those aspects as well. But thank you to speakers for joining in, and thank you for all the folks who have trickled in. We'll get started with John, who will talk about some of the problem statements he's seen within his journey as a lab automation person, and what opportunities and vision he has within this domain as well. If you have any questions, feel free to write that in the chat itself, and we will make sure we address it after the session in the Q&A, or we can follow up with you individually as well. So without further ado, John, if you don't mind getting started, that'd be awesome.
Yeah, absolutely. We'll just jump right in. So I'm going to start by highlighting a couple areas of opportunity in lab automation that I think we can address with a more modern software stack. The first thing that I'll talk about is this idea of modularity and bespoke experimentation. So one of the challenges that we have in lab automation is that even the most advanced systems and architecture struggle to provide the kind of modularity that bespoke experimentation demands, while simultaneously being able to operate as a production line or assembly line. So as a result, your manual methods, despite their inefficiencies, are still kind of the go-to tool in the scientist's arsenal, specifically in research settings, but also in kind of a operations lab like ours. The next item is this idea of complexity and testing environments. So we have this interesting paradigm where as lab automation becomes more complicated, the reliability of the testing environments decreases. And that's particularly evident in larger integrations and lab orchestration like we see here at Invitae. And this concept of the digital twin, which is pretty common in a lot of software engineering disciplines, is completely foreign to lab automation. And so we usually end up doing testing directly on our production equipment, which is a kind of a frightening thought. And as a result, what we actually do is whenever we're doing any sort of build, we'll build two of everything. That allows us to take one thing down, fix it, do some testing, bring it online, generate some data, revert back to the old thing, evaluate the data. Then it's this juggling operation. So, and then the last thing is this idea of version control and data capture. So a significant pain point in today's labs is the absence of effective version control and comprehensive data capture mechanisms, especially labs like ours, where the lab is the factory of producing data. So the industry standard low-code software that we have almost always requires us to build additional libraries or plugins to kind of manage run data, communicate with our external services, and that interdependence of software and hardware makes versioning really, really challenging. So kind of there's some opportunity there for sure. So we can jump over to the next slide. Okay. So then here I'm just going to kind of talk about what I imagine a vision for the future, kind of like maybe a 2 to 5 year vision. Although I think what you'll see kind of as the talk goes on is that a lot of these software concepts or tools that I have in my mind are things that are actually kind of already there. So SciSpot will probably have a bunch of products that hit these different areas directly. So that'll be kind of an interesting thing to explore. So it's not that any of these things are necessarily novel. It's that having them all in kind of one unified spot is novel. So, so kind of the vision here is leverage proven scalable best practices and tools from successful tech companies to modernize the lab automation software stack, which will ultimately drive scientific discoveries and process innovation. So I think a lot of these key components are within reach and would have a significant impact in the opportunity areas that I highlighted before. So the first thing is, the first thing is defining the entire lab process as code. So ultimately just unifying the definition of lab work into a single schema so that you're removing these redundant definitions of, say, the orchestration layer, actually the limbs layer, the orchestration layer, the scheduling layer, and the liquid handling layer. There's a bunch of definitions that are redundant that I think we could consolidate into a single definition. And what that's going to do is promote reusability, portability, version control. It's probably aspirational to drive the liquid handlers directly, although I do know that there are some interesting efforts out there to do that. So aspirational, but I think achievable. The next thing is this idea of automating the versioning of the code and capturing all the dependencies. So first, that requires that our automation methods play nicely with version control, but then the automation part is pretty straightforward. And I think using tools like GitHub Actions and Artifactory can get us there pretty quickly. Next thing is this automation of the deployment of the code. So if we have this lab controller that's working with the versioning and definition of the lab, then we have these agents sitting on every lab computer. And by virtue of having the controller and the agents, we can kind of solve the deployment problem. And they're going to get the right code in the right place on each of those PCs or lab controllers. Next thing is this kind of holistic definition of the lab itself in terms of code, specifically in terms of code. So here, we don't just want versions of the code, like versions of the methods. What we want to actually do is assign and manage versions of configurations of code. So a particular integrated work cell may use a bunch of different repositories, a bunch of different artifacts. We want to capture all of those artifacts, all of the dependencies, and version that, and kind of automate the bumping of those versions. So that's going to also be done in this idea of this lab controller. Next thing is observability. So capture telemetry data from all of our instrumentation software and kind of really bring observability into lab automation, enable that complete data capture. Next thing is go ahead and retire all of our desktop scheduling software for a single unified cloud native scheduler. What that's going to do is that scheduler is going to be out of the box a better test harness. So you're going to build that with testing in mind. It's going to communicate with your lab controller. It's going to communicate with your digital twins. You can kind of get feedback from runs. I think the scheduler itself is definitely an area of opportunity. And then lastly, we need connections to our LIMS systems. So this idea of connectors. So we're not going to retire LIMS, but what we might want to do is make it much easier to attach your LIMS data to your data that you're generating in the lab. So whether that's particular key events or key pieces of data, we just want to kind of seamlessly connect LIMS to our scheduling software.
That's awesome. Oh, John, one question I had was, as you're explaining this, why do you think like the industry is so fragmented? Because none of this is unique to the tech industry, right? We've been having CI/CD pipelines for last decade. We have version history well established. I know some instruments have this Windows machine, and scheduling and orchestration can be hard depending on the lab instruments. But would love your thoughts on like why do you think it's still so fragmented, and a bit of color on that would be great because I've noticed that as well a lot.
Yeah, I think there's a couple. So specifically for version control, I think there's a couple reasons why that's so challenging. Number one is in the automation industry as a whole. So controls engineering. So beyond lab automation, version control is really challenging. Those industries also struggle with it. It's not just lab automation. We also have this extra problem where lab automation engineers are not software engineers, and so from the start, we're going to struggle with things that computer scientists feel are obvious. We don't know what tools are out there. We maybe don't even know how to use semantic versioning at all. So you end up at each lab, they're going to have some unique way of doing it. that's not sustainable. I've never seen a sustainable version of this. And then as far as like why it's so fragmented, every hardware manufacturer is making their own unique software to control their hardware, and the industry never really decided to unify under some communication protocol. So we have this idea of SELA and SELA 2, which are meant to do that exact thing, and yet vendors still just don't do it. And so as a result, it's not like building these things called drivers where we're actually linking the hardware interface to our scheduling software. It's not straightforward. And then lastly, pharma has walled gardens of development. So a lot of the unique stuff that we build, we don't share. We either because we don't want to, we see it as a competitive advantage, or we just don't have a place to share it. So it kind of you do a bunch of unique engineering at Invitae that nobody else has, and it's like, do we give it away for free? Who's going to do it first? All of that stuff. So
Makes sense, but I think there's definitely opportunity to like bring this all together. And as you said, it's not like novel in itself. It's just the combination is like unique and novel. We've already got a couple of questions. One is that do you control hardware with SciSpot through a server? Yes. Short answer is yes, depending on what type of hardware you're referring to. And then I think the next question is, so I'll cover the SciSpot roadmap and features in detail shortly, so we can answer this in more detail. The second question is, can you talk about, I think it's from Catherine. Uh, John, I would let you answer this. Can you talk about how you would imagine toggling between dev and production system using this vision that you've just highlighted?
yeah, I think the idea of the holistic definition of the lab, you could by essentially you're defining versions of configurations of code, and so within that you can assign tags such as I mean they're kind of arbitrary tags, but prod, stage, dev, right? And so using that definition and by virtue of the fact that the controller and the agents are managing what code is on what computer at what time, you can make sure that you're running your dev code, for example, or you're running your stage code. It's much easier to imagine the component where you're hitting a stage instance of your LIMS system if LIMS is connected back to your scheduler in some kind of easy to manage way. So that kind of idea of the connectors is important there as well.
Brilliant. Yeah. So if Catherine, this makes sense, or if you have any follow up questions, feel free to add it on the chat itself. And if any of these problem statements or vision resonate with you, or if you've got more ideas, we'd love to hear from the community. So again, feel free to like add it to the chat. Was there anything else, John, you wanted to mention before we move to Jesse?
No, that's it.
Brilliant. So we have our next speaker, Jesse, before the usual suspect, me, kind of comes in. So I'll let Jesse talk about some of the challenges and vision that he has seen and what opportunities do we have, especially when it comes to data in this domain. So Jesse, over to you.
Thanks. Yeah, so I'm going to talk about a lot of the sort of things downstream of automation. That is what happens when you get the data out and it's time for your data team, your analysts to do something with it. And you'll see that there's going to be a lot of overlap between, particularly on the challenges that I'm going to talk about. And that's because I think, I'm really excited about what's happening in the automation space because, well, on the one hand, it's obvious sort of if you can get automation working, you can get data a lot faster, power the big ML models. That's important. But there's a less obvious advantage, which is that, as I'm going to talk about, a lot of the problems that come up in automation, if you can solve them, they will help solve a lot of the problems that come up with data analysis and getting data to the people who need it. And so the way I like to think about the first of these is the process versus the static summary of the process view versus the static summary of an experiment. So if you're in the wet lab, it's usually best to think about an experiment in terms of the process that you follow in order to get your biological model set up before you send it off to get the readout. And that's because, so the kind of flippant way I like to think about it is biology doesn't work, right? At least it doesn't work in the way that physics works, where you have rules and things tend to be repeatable. In biology, there's a lot more corner cases. It's more guidelines, and so often experiments involve a lot of very intricate details that are really there to work around those corner cases. Maybe your cell line needs particular treatment in order to make sure it will survive long enough. The biological model needs very specific conditions in order for the readouts to be valid, things like that. And so when someone in the wet lab is thinking about the experiment, they're thinking about all the ways it can go wrong and all those very detailed things that they need to do to make it work. If you're then handing that to someone on the data team, a data scientist or a computational biologist, they really just need to know that static view of what were the conditions that you were set up and what was the results, what was the readout. And so in the old days, I guess this is not just in the old days, but if you're having the same person, that wet lab person, also doing the analysis, they can often implicitly kind of translate that process view into the static view that they need to do the analysis. But when they're working with a separate data team and they need to very explicitly, deliberately translate from process to static, that's actually kind of hard to do. Like many forms of communication, it's hard to kind of say what you mean to someone, communicate that to someone else. And so that is kind of a very fundamental barrier to that needs to be worked around. And that kind of leads into this flexibility versus consistency, which we also saw in the automation space, where in order to handle all of those corner cases and all of those ways in which biology doesn't work, the biologist, the wet lab person, needs to have a lot of flexibility in how they define experiments. And of course, this makes automation difficult because they need to, you need to have a flexible enough way of describing that to the instruments. But it also means that when they're passing that data on to the data analysis team, that process view is going to have a lot of details about that specific experiment. On the other hand, for the data teams,
No, it's all good. I just removed the audience from the scene, so I'll let you kind of focus just speaking.
Sorry, making sure my internet wasn't going out. So one thing that's changed a lot, especially in the last few years, is that biotechs are much more looking at multiple experiments, trying to do analysis across multiple experiments and readouts in ways that they just weren't able to do before. But now, as that becomes more and more possible, of course, that becomes more and more important to what a lot of biotechs are doing. And so if you have this individual, very detailed view of your experiments, that can actually get in the way of this, because as a data team who wants to look across multiple experiments, you're much more interested in what's the same about the experiments and where things are different, what's the pattern for how those differences are going to occur. And so if you have this detailed process view, that actually can get in the way of recognizing those patterns, especially if you're relying on someone else to translate that for you. And in fact, what you'll see is often when there are delays in doing analysis, in processing data that's come out of the lab, often the delays aren't on the analysis side. They're actually on getting that information about what the experiment was, getting that static view of the experiment, whether it's a plate map or a sample sheet or some other kind of description. That tends, at least in my experience, is more often the cause of the delays compared to once you've gotten that all in place and you can do the analysis. And so if you kind of go even upstream from this, the third challenge, which is sort of a little more distantly related, but is that often the experiment planning itself is done separately from with a separate team from the folks doing the analysis, right? Before you would have separate data science teams, and where the biologist was doing the end-to-end process, they would also be doing the planning. And so many folks in the wet lab are used to just doing the planning by themselves and don't necessarily try to pull the downstream analysts into it. And the problem with that is, if you think of experiments as being basically activities to generate data, or rather as ways of filling gaps in the data that you have, then you see that the folks who are doing the analysis are going to have a particular view of what those gaps are. And if they can't give that feedback to the planning process, then of course those gaps are not going to be addressed or may not be addressed. And so you're basically taking a valuable source of information about what those experiments should be, and you're ignoring it if you're not incorporating the downstream analysis teams into planning, and kind of thinking of it as the biologists plan and do the experiment and then throw the data over the wall. And so I think if you look at what the vision should be for this, and this is much more simpler, a little bit more abstract than what John presented, but basically I think it's much more important to have collaboration between the wet lab and the digital teams, both to make sure that you're filling the right gaps in your data sets, and also to make sure that the digital teams are kind of in the loop on the experiment planning process and know what to expect once the data comes out, and they can kind of hit the ground running, get the analysis done as quickly as possible. If you can create this more formal planning process and you have the right software in place, then you can start defining these detailed experiment definitions before the experiment starts, and have everyone on board, and have a actual place where it's all written down, and folks can review it, make sure that you're not missing anything. And from there, then we can get into this kind of detailed digital format for defining the experiment process. And again, this should be something, or could be something, that could also feed into the automation. And so if you can solve that problem at the automation level, that also gives you a good way of solving it for the kind of downstream analysis. And once you have that in place, then it just becomes a relatively straightforward technical problem to put in place this sort of automated merging of experiment details and readouts. And of course, this is something that SciSpot can do. But if you can get all these pieces in place, then you can get to a point where as soon as that readout completes and the data is there, your digital team will also know, they'll have the plate maps or the sample sheets or whatever it is that will allow them to actually interpret and analyze that data. So you'll drastically cut down on delays in getting the analysis. And of course, if all this is automated, that there won't be typos and manual errors. And so you'll also be much more have much more confidence that the data and therefore the analysis is correct.
Just one question. Sorry, I didn't mean to interrupt, but
I was concluding a sentence. Go ahead.
No, after you.
I was going to say, so this is kind of the vision. I think if you can get this in place, then you'll be, much better off.
So one question I've heard over and over again from the community is whose responsibility should it be to formulate the process, especially when it's linking the wet lab and the computational folks in that feedback loop. So have you seen any examples of who leads this kind of process design and implementation in a biotech company?
Yeah, I mean, I think so. Obviously, it depends a lot on the company, depending, and I think often it kind of comes down to personality. Who has the right personality to kind of do this cross-team work. Often it ends up falling on the digital teams, just because I think there's sort of, you tend to fall into this position where, since they're the new kid on the block coming in and saying, hey, we can do all this great stuff for you, it's up to them to prove that they can do it, right? And so the onus falls on them to get the process in place that will allow them to do the things that they promised. And I think this is often unfortunate, both because if they don't understand how biotechs work, it's much harder for them to figure out what this process should look like. They often don't feel empowered to make those kinds of changes, because the biologists are busy. They don't want to take up their time by making them do things that, might speed up the downstream analysis even more. So I think there's a lot of kind of social and cultural impediments to that. And so I think, again, ultimately it comes down to the individual organization who should do it. But certainly, I mean, if I can kind of plug my consulting work, having seen this, I think I like to come in and help teams make those changes and kind of push back on the processes that aren't working and get this in place.
Brilliant. And somebody is digging next to my house, so apologies if there's a background noise. But one other question, Jesse, is in terms of influencing this culture, do you see there is an opportunity to reduce variables as well in biotech? Because biotech is inherently so much more, has so much more variability compared to traditional tech industry. I mean, I come from travel tech, and I've seen travel tech, you could just automate everything end to end. There's the percentage of variability is really low. Have you do you think next 10 years, 20 years down the line, we might be able to reduce the variability in biology inherently, or do you think this would not change?
So, as not someone who's not a biologist and not even sort of hasn't spent as much time in an automation lab as John has, I have to be a little careful about making predictions on that side, because I think a lot of it comes down to the biology, right? It comes down to the fact that there's all these corner cases, there's sort of guidelines versus rules, and so from what I've seen, my guess is that the goal shouldn't be to reduce the complexity of the biology, because that's going to continue to be messy. Instead, the goal should be to kind of firewall that complexity from the people who don't need to see it, right? I think in the lab, there's always going to be those, issues with, platelets getting stuck and, arms deciding to drop things, and and cell lines just mysteriously deciding to die for no reason, right? So I think trying to get rid of that complexity is a fool's errand. But on the other hand, and of course, if there's any biologists watching who want to correct me, you can. But I think it really should be about kind of managing that complexity and translating it into something that's simpler, so that the folks doing the downstream analysis can focus on the variability that they care about and not have to worry about what's happening in the lab. And also automating as much of this so that the folks who do need to worry about the details in the lab don't need to take up time and energy to translate it into that form that the downstream analysis requires.
Makes sense. And Igor has a question.
Oh, sorry. I was going to ask John what he thought about that, because I think he might
sure.
be in a better position to.
Yeah, I mean, coming from the perspective of lab automation, data generation isn't necessarily hard, but most of that data doesn't go anywhere. So this kind of highlights bringing observability into the lab. So at least trying to get the data out of a PC where it's not useful and into somewhere where you can actually use it to actually get context for whether something is important or not. So we kind of have this problem where at the bench, a scientist is perfectly capable of running an experiment, and they maybe are not capable of documenting exactly what it is that they're doing that makes it run. And this goes back to the reproducibility crisis. As you know, it's kind of like the tagline is basically, I could do something in my lab and have it work perfectly well. You could read my SOP and you cannot do it at your lab, and that's a problem. So more automation helps with that, more documentation, more granular methods, more data capture is going to make it such that you can reproduce it. And kind of that's the goal. So we also have this catch-22 of me asking the AI engineer, like, what data do you need to get the insights you want? And them saying, well, what data can you give me? So we don't know what to do. So nothing changes. So for now, I think the best approach is there are a bunch of observability tools out there. Let's just start plugging them into our lab automation software and send that data somewhere, and that's like the starting point. But yeah.
Brilliant. Makes sense. We have a question from Igor which says, have you considered the diverse challenges associated with data input, storage location, and typically incompatible formats? Additionally, the tools for translation and automation demand significant investment from the pharmaceutical industry. Would that be satisfactory? So, John, do you want to take a stab at it? It'd be good to get thoughts from Jesse as well.
Yeah, it's like a hot topic right now. It's basically blowing through our data storage cap by sending all of the data. So there is different telemetry that's more or less useful. And so I think it's more just making sure that you're instrumenting your software correctly so that you're not just sending a bunch of garbage to the data store. There's very useful lightweight data that we can capture that will tell us essentially every event that's happening in the lab. And if you add a little extra context, like a workflow tag or a plate barcode or something like that, you can kind of create a cohesive story.
And I also wanted to take this opportunity to talk about SciSpot glue. So SciSpot glue does exactly that. That's essentially the definition of SciSpot glue. So we'll cover those slides shortly. But I'll let Jesse, if he wants to add anything, I want to give him an opportunity before we move to the next part of the agenda.
No, I think I think John summarized it well.
Brilliant. So finally, the agenda is about SciSpot. So you heard from Jesse and John the challenges and the vision statement. And this topic was brought to us by the SciSpot community, and that's why we did this session. So I'm going to talk a little bit about SciSpot's roadmap and what it can do right now and what we're working towards, and would love feedback from the community to see if it makes sense or if you have any ideas or suggestions. So again, I apologize for the background sound, but hopefully I'm loud and clear. So moving to the next slide. In terms of the SciSpot toolkit, there's like four key elements. So one is Glue, where you can basically connect with different diverse data input, storage location, incompatible formats, and basically pull and push data, but also schedule data. One of the challenges we've seen is a lot of tools out there can easily pull and push through APIs, but scheduling becomes a problem. So, and also if the schema changes on the source side, so let's say if you're bringing data from certain LIMS or ELN systems and then stitching it with your plate reader data or your instrument data, that's where the glue use case kind of comes in. And then there's wet lab tools. So there's a UI feature for SciSpot limb system, which we call lab sheets. And for the Notion for Science, as we call it, it's SciSpot lab spaces, where you can run any of the notes or your databases programmatically or through UI itself. So let's say if you're building a sample management system, you can build that through GUI if you're a wet lab person, and connect that with your instrument data, connect that with your Tecan Hamilton robots. You can also do that programmatically. So there's an API link, docs.scipod.com. If you want to check it out, you can see like how you can programmatically do a lot of wet lab and computational work within SciSpot using a flat but like connected schema of APIs. Because one of the things that we noticed over the last couple of years was in this industry, like there are not many tools that are built with an API first mentality, and that was what our focus was. Like, how can we build SciSpot with an API first focus, not just UI, but also giving computational folks to be able to programmatically create plates, programmatically create barcodes, so you can check out that documentation in more detail. And then lastly, one other call out I want to mention is the embedded Jupyter Hub and R Studio. So within SciSpot platform, as you're bringing data from like different disparate sources, you can run commands, use templates, and those are like embedded Jupyter server and embedded R Studio, depending on. There's a debate of like whether people prefer Python versus R, so I'm not going to go into that debate. But something that I've seen like a lot of labs use, along with the UI features as well. Okay, so how do you run lab as a CI/CD pipeline? What do we already have right now within the platform? So some of the labs are already like connecting their GitHub repo with the SciSpot Jupyter Hub or RStudio, for instance, and using the API to be able to connect with robots, whether that's Hamilton or Tecan. And then we also run into the same challenges of like SciSpot agents running on the Windows machine, and having like a central scheduler is super helpful. So we are solving that challenges with some of the labs. As John mentioned, like some of the instruments are still not there when it comes to like the technology, and agents can become like quite disparate and disconnected. So that's one of the problems that we're working on with a lot of labs right now. So we bring that data into cloud and then stitch it with the rest of the glue sources. And then you can basically run this whole supply chain of lab in a workflow or orchestration. This orchestration can be controlled through API, through commands, through simple English language commands. And now what we're working on is like a workflow designer, so like a UI on top of it. So what you can do through the API, you can also do that through the workflow designer as well. But a couple of things that I've noticed a lot. One is when folks bring in their data into SciSpot lab sheets, they then do transformation using some of the templates. Some folks use that as a data lake. Some folks use it as a staging lake house. So staging lake house meaning they do a lot of pre-processing, post-processing on the data, and then push it to Snowflake or Databricks if they have their own proprietary data lake. And some of the folks I've seen, they push data into like Neo4j to build their knowledge graph to see like how their entities are connected. So let's say if I'm running a workflow where I have protein, peptides, run cell lines, I want to see the whole entity diagram. I push it to Neo4j and be able to see the relationship of my knowledge graph. And that's also like I'm seeing a lot within the industry. So would love to hear your thoughts, like how do you explain your research, and then how do you connect it with your AI pipelines downstream? Because as LLMs are getting democratized, I think improving the noise to signal ratio is very important, because otherwise your AI models would have garbage in, garbage out, right? So I would love to hear thoughts on like how folks are solving that problem. And are they converting lab as code? Are they stitching the workflows between wet lab and computational folks? Any thoughts there would be amazing. And lastly, in terms of the roadmap, so would love to hear from the community of what else you would like to see within SciSpot. What we've already done so far, as I mentioned, is Glue, having secure APIs, having a scheduler that connects with your metadata and data in your LIMS system, having a workflow designer using API with embedded Jupyter Hub and RStudio, and be able to design your own data model using the API. So LabSheet basically lets you design your data model, connect your, let's say, ELN data with your plate reader data, with your instrument data, and make it fair, tag it appropriately. So that part, like, we've solved really well. The part that we're currently working on is basically building the scheduler web application, because a lot of wet lab people want some sort of UI to be able to set triggers. So working with some customers to, like, how do you configure those triggers from the UI itself? And the other part is, can wet lab people run English language commands rather than be able to rely on the computational folks to do any programmatic stuff on their limb system? So that part really excites me, because if wet lab folks can, like, do programmatic things, connect different metadata and data just by English language commands, I think that would be huge, right? And then we're basically breaking down the barriers between wet lab and computational folks that Jesse talked about. So yeah, those are some of the roadmap items. I would love to hear from the community if there's any more questions. Anything else, John, you want to add before we open up for questions, and Jesse as well after John?
I don't think so. I think like this idea of adding the LLM on top of the workflow designer is very interesting because, again, as I said before, you have lab automation engineers who are not software engineers. So moving to a lab as code exclusively is probably not what you should do for step one, because you're going to have nobody that can use the product. So having a GUI or having this like LLM on top of it is super useful. I can imagine like feeding in a prompt. I want to create a workflow that's broken into 3 sub workflows and like dive into the details of each of those. And all of a sudden I have a perfectly built SciSpot workflow that I didn't have to learn how intricate SciSpot is in the background. Like, to me, that sounds super useful.
Yeah, I'm excited about that as well. I think it would break down a lot of barriers, and it would also help, like, make you do less clicks. I feel like this whole clicking would become like software of the past, where you have to go to UI to click, click, click. You do 20 clicks and then you get to a destination. And I feel like the next step is, I don't want to predict the future, but next step is more conversing. And then after that, it'd be all voice. I think we're still far away from the voice. Again, I'm just speculating here, but I feel like going from click to more commands and then from commands to actually literally voice is the journey. Um, but we'll see what the future kind of brings in this domain. Jesse, do you have any thoughts?
I guess I was, I guess I've been more and more thinking about LLMs kind of more as learning tools than as repeated use tools. So what I've found, and again, this from kind of the software engineering side, is that often when you learn a new tool, you kind of want the simplest version of it, and you'd rather just have like a voice interface and and kind of not know what's going on below the hood. But then the more you use it and the more you really understand how it works, it actually becomes more efficient to do some, to like use your keyboard more and your mouse less. And so I think I kind of want to think about LLMs as kind of the bridge that makes that happen faster. Where the first time you're using a tool, you ask the LLM, "Hey, how do I set this up?" And it gives you back the config, and you check it and say go. And then you kind of learn how to write the configs, and then at some point maybe you don't need the LLM anymore, and it's faster for you just to go in there and kind of work like an expert. So I think that could also be a really really interesting model for this in the context of SciSpot or anything else.
Brilliant. We have one question which says, can SciSpot API assist in automating plate creation and connecting with robots? So short answer is yes. Our customers programmatically design and load plates and control liquid handlers and bring data back using SciSpot glue. So happy to, like, do a demo. And somebody mentioned, agreed, LLMs are the best learning tools. So yeah, plus one to that. What I'll do is, if there's no more questions, I'll add my Calendly. And Jesse, if you want to share your Substack as well in the chat, that'd be great. So feel free to, like, schedule demo with me on Calendly. And John, if you're comfortable sharing your details and folks can reach out to you for any questions as well, that'd be awesome as well. And this session was recorded and it was live. And LinkedIn usually, like, breaks the link. I think there's a bug in LinkedIn, but the live does go operational in LinkedIn after 10 minutes. So it did go live. So you can also watch the recording on LinkedIn as well. But yeah, thank you for taking the time on a Tuesday. I don't even know what day it is. I think it's Tuesday afternoon for folks joining in North America, morning, afternoon, and a couple of folks were from Europe as well. So thank you so much for joining in, and feel free to reach out to me or John, Jesse, anybody. And yeah, thank you.
Thanks, Satya. Thanks, everyone.
Yeah, thanks.
Thank you, folks. Cheers. Bye bye.